So today we are going to multiply polynomials by a monomial. So we're going to take some kind of polynomial, whether it's one term like a monomial or two terms or three terms joined by addition or subtraction, and we're going to multiply them by a polynomial on the outside. So this first example says when you multiply like bases with exponents, so here's what they mean by like bases. Remember that you keep the base and you what the exponents? Add. Good job. So when I look at example number 1, I'm going to kind of write out what's happening. You have 7 times 3, and then you have x times x squared. Well, 7 times 3 is 21. And remember, this x all by itself has a power of 1. So the bases are the same. I'm going to add my exponents. So that becomes 21x cubed. Does that make sense? Okay. The next one, again, we're going to multiply the constants. So I really have 7 times -2 and x times x. Those x's are to the power of 1. 7 times -2 is -14. X times x is x squared. Are we good with that? The last one, I have 7 times -5, and then I'm just multiplying by an x. So that becomes -35x. Okay. When multiplying polynomials by a monomial, the rule still applies. You're just multiplying all the way through. You're multiplying all the way through. So for example number 4, I'm going to draw little arrows here so you can see what's happening. And then I'm going to write these as a multiplication problem. So we really have 7x times 3x squared. And then I have 7x times a -2x. And I have 7x times a -5. Notice I didn't put any, there are no signs right here. Like I didn't put plus or minus in there. Those signs are attached to the term that I'm being multiplied by, right? Because remember that the sign is attached to the term that comes after it. So 7 times 3 is 21. And x to the first times x squared is x cubed. Now I'm going to take 7 times -2, which is -14. That's where the minus sign comes in. And my x's, I have x to the first times x to the first, which becomes x squared. And then I have a 7 times a -5, which is -35. That's where my last minus sign comes in. And the x just comes down for the ride. Notice that this example is really example 1, 2, and 3 spread apart. Do you guys see that? Okay. Let's do example number 5. Again, I'm going to take this term on the outside and multiply it by each term on the inside. So I really have 6x times 6x squared. And I have 6x times 3x. And I have 6x times 7. You guys might be able to go without writing it out like this, expanding it like this. I'm just trying to show you, I guess, a better way. I don't know. 6 times 6 is 36. I'm going to add a 1 to that x. So when I multiply my bases, x's are the same. I keep the base and I add the exponents. That becomes x cubed. These are 6 times 3 is a positive. That's where my sign comes in, 18. And x to the first power times x to the first power becomes x squared. 6 times 7 is a positive 42. That's where my sign comes in. And just bring down your x. Thoughts? You just feel okay with that? All right. When you simplify expressions, remember that you're going to distribute, remembering to add the exponents, and you're going to combine like terms and making sure that you put them in descending order. Descending order, meaning you want the largest exponent term to come first. We call that the largest degree. You want the largest degree monomial first, okay? So I'm going to do it the same exact way. I'm going to expand both of these so we can figure out exactly what's happening. The first thing I'm going to do is draw arrows over the top. I am multiplying the second parenthesis by a negative x. So if I expand this, I really have 4 times 3x squared. And I have 4 times a positive 5x. And then I have a negative x times x squared. And I have a negative x times a negative 2x. And I have a negative x times a positive 10. So we're going to first of all multiply and then combine like terms. So 4 times 3 is 12. And I don't change the x because it's not being multiplied by another x. So I just have x squared. 4 times a positive 5 is a positive 20. And bring down your x. Now here's where I have to remember that I'm multiplying by a negative. This x has a power of 1. So I have negative x to the first times x squared. So the negative is going to stay there. And I'm just taking x to the first times x squared, which is x cubed. In my second example, I have a negative number times a negative number, which means that I'm going to have a positive or a plus 2x to the second power, or x squared, minus, because I have a negative, times 10 and x, so minus 10x. So now I'm going to kind of look at these and say, well, which term has the largest degree? Because now I need to put these in order. So what's the largest degreed term? Anyone? It's a negative x cubed. Do you see that? So I have a negative x cubed. That needs to come first. So now I'm focusing on my x squareds. Well, let's see. I have an x squared right here. And I have an x squared right here. So I need to combine like terms. What is 12x squared plus 2x squared? So plus 14x squared. Last, I'm going to look at my x to the power of 1. So I have a positive 20x and a negative 10x. 20 minus 10 is positive 10x. So this is after we distributed and then combined like terms. So we simplified that expression. So for the next one, do I have to write it out? Can I skip this step right here? Can we try that? Okay. So 2x times 3x squared. Let's see. 2 times 3 is 6. X to the first times x squared becomes x cubed. 2 times a negative 5 is negative 10. And I'm just going to bring my x along for the ride. Are you guys okay with that? All right. Now I'm going to take this positive 7 and multiply it by both terms in that parenthesis. So 7 times x is a positive 7x. And 7 times negative 4 is a negative 28. Last term, I have a positive 6x, and I'm going to multiply it by each term inside the parenthesis. 6x times x becomes a positive 6x squared. Good job. 6 times negative 5 is negative 30. Bring your x along for the ride. So now we need to put it in order. Largest degree monomial first. Well, our largest degree actually is already first. So I'm just going to bring that down. I'm starting off with the 6x cubed. So I took care of that one. Next, I'm going to look for x squareds. So I have a positive 6x squared, and I don't see any other x squareds. Do you guys? Okay, so I'm just going to write that as plus 6x squared. And then I'm going to look at my x to the power of 1, and I have 3 of them. So I have a negative 10, positive 7, negative 30. So negative 10 plus 7 is negative 3. Negative 30 and negative 3 is negative 33. X. And last, I'm just going to bring that minus 28 down because there are no other constants. Remember that we said a constant is degree what? Do you remember from yesterday? It is a constant has degree 0 because, I think it's important to know why, if I took 28 times x to the 0 power, what is x to the 0 power? That's the same thing as saying 28 times 1. And remember, the degree comes from the exponent on the variable. That's why constants are degree 0. Okay? I want you to make sure you understand that. I think the notes are pretty short and sweet today. So we're going to move down to areas of figures with polynomial side lengths. So our first one is going to be a rectangle and then the triangle. So we need to figure out the formula. Someone tell me the area of a rectangle. God bless you. Yeah, I heard someone say it. It's L times W, length times width. Area of a triangle, base times height, divided by 2. Good job. Base times height, divided by 2. Okay. Remember that the base and the height are always perpendicular to each other. Your base and your height are always perpendicular to each other. So I'm just going to find the expression for the area of this rectangle. So I think it's going to be easier to put this term outside the parenthesis and multiply it by this large term we'll put inside the parenthesis. So I'm going to write it as 3x squared times 2x squared plus 5x plus 1. So I'm going to distribute, multiply the guy on the outside by each term on the inside. So 3 times 2 is 6. And x squared times x squared becomes x to the 2 plus 2 is 4. 3 times 5 is a positive 15. And x squared times x to the first is x to the power of 3. Last one, 3 times 1 is a positive 3. And x squared, there's no x to multiply it by, so that just comes along for the right. And that is in descending order, largest first. Are y'all okay with that one? Good? Okay. So let's look at the next one. So the base times the height. I know that the 6x is my height, but I'm going to put it on the outside of the parenthesis. 6x times the quantity, 10x plus 4. And then this whole thing is going to get divided by 2. All right, so we're going to take 6x times 10x and 6x times a positive 4. We're going to do that first. So 6x, 6 times 10 is 60. X to the first times x to the first becomes x squared. Are you guys okay with that? And then 6x times 4 is a positive. 6 times 4 is 24. The x comes along for the ride. The whole thing is getting divided by 2. What does that mean when I'm dividing the whole thing by 2? Every term gets divided by 2. So it really means this, 60x squared divided by 2 plus 24x divided by 2. And that equals 60 divided by 2 is 30x squared. And 24x divided by 2 is 12x. Does that make sense? Okay. So our last couple examples, imagine like we're given the area and a side length and we're trying to figure out the other one. So we have to divide. Where did that just go? Hang on a second. My notes just disappeared. Undo. Okay. That was crazy. Okay. So dividing a polynomial by a monomial, you divide each term. Each term in the top gets divided by each term in the bottom. But remember, what is the rule about dividing exponents? What is the rule about dividing exponents? If we divide powers with the same base, what do we do with the exponents? We subtract them. Okay. So for these, I'm going to expand them just so you can see exactly what's happening. So for example 10, I really have 20x to the 5th divided by 4x cubed minus 16x to the 4th divided by 4x cubed plus 24x cubed divided by 4x cubed. So let's look at the first one. What is 20 divided by 4? It's 5. I'm going to subtract the exponents. 5x to the 5 minus 3. I'm just going to leave it like that for a second. Minus, what is 16 divided by 4? 4. And then I'm going to subtract my exponents to the power of x to the 4 minus 3. What is 24 divided by 4? 6. And my exponents, x to the power of 3 minus 3. So now I'm going to simplify those. So I have 5x to the power of 5 minus 3 is 2. And negative 4x to the power of, so I'm not going to write it, plus 6. And x is to the power of, which means that it's a 1. 6 times 1 is 6. So we leave it just like this. So that's using the exponent rule. Here's another way to look at it. So I'm just going to write the first couple of terms down. We know that 20 divided by 4 is 5. Do you have more x's on the top or on the bottom? On the top. How many more? So they stay on the top, 5x squared. Do you guys remember me doing that with you when we did the exponent rules? Okay. So we're going to kind of try and do that with this next one. So I'm going to expand it, but I'm not going to use the subtraction rule. I'm just going to have us like kind of think about where the exponents are. So 21x to the 4th y over 7x squared y plus 49x cubed y over 7x squared y. So let's look at our very first term, which is 14x squared y divided by 7x squared y. 14 divided by 7 is 2. Do you have more x's on the top or on the bottom? They're the same, so they cancel each other out. Do you have more y's on the top or on the bottom? They're the same, so they cancel each other out. Let's look at the next one. Negative 21 divided by 7 is negative 3. Do you have more x's on the top or on the bottom? The top. How many more? So that becomes x squared. Do you have more y's on the top or more y's on the bottom? So they cancel each other out. Let's do positive 49 divided by 7. 49 divided by 7 is a positive 7. Now I'm going to look at my x's. Do I have more x's on the top 4 on the bottom. On the top, how many more? Okay. Do I have more y's on the top or on the bottom? So they cancel out. So now I just have to put this in descending order because it's not. The largest degreed monomial is negative 3x squared plus 7x. And then that last one, 2 is positive, so plus 2. We have one lone word problem on a whole piece of paper. Does everybody have this? Are we good? Okay. So this is our last question. It says, find the missing side of a rectangle if the area 10x plus 20x squared plus 35x cubed with a width of 5x. So we're trying to find the length. That's what we're trying to find. We don't know what that is. So if I want to find the length, I can take the area, which is 10x plus 20x squared plus 35x cubed, and I can divide that by the width, which is 5x. Okay. 10 divided by 5 is 2. Do you have more x's on the top or on the bottom? The same. So they do what? Cancel each other out. Now let's look at the next term. 20 divided by 5 is, and it's a positive 20, so plus 4. Do you have more x's on the top or on the bottom? How many more? Okay. 35 divided by 5 is 7. Do you have more x's on the top or on the bottom? How many more? So now we just need to put it in descending order. So my length is what? What's the largest degree monomial that has to come first? 7x squared. And the next one? Positive 4x. And the last one? Yep, there you go. You guys feel okay with that? Okay. So your homework for today is pages 8 and 9.